The objective of this lesson is to apply independent and dependent variables to problem situations. Before we start, let's talk about some vocabulary words. The independent variable is the input value that is on the x-axis. So independent is input, and it represents the x values. The dependent variable is the output value on the y-axis. So dependent is output, and it represents the y values. An easy way to help you remember this is this acronym. Dr. XY needs his ID in the office. D, of course, stands for domain, which represents the x values. It's also the input and the independent variable. R stands for range, which is the y values, which represents the dependent variable and the output. We say that the value of the dependent variable depends on the value of the independent variable. Another way of saying that same thing is that the dependent variable is a function of the independent variable. Let's try some examples. Number 1, on average, Jay can ride his bike 12 miles in 1 hour. The function m equals 12h represents the number of miles m he can ride in h hours. They're asking us for the input variable. The easiest way to think about this is to think about your equation as if it had a house around the inside of the equation. So a 12 and an h are inside the house together, and m is on the outside. If we label our variables, h is on the inside, so I'll label it I, which stands for input, independent. It's also the domain. M is on the outside of the house, so it is the output, which also means it's the y value, and it's the range. So our input variable, we can see, is h, which stands for the number of hours he rides his bike. The output variable on the outside is m, which represents the number of miles. So now, using our new vocabulary words, we're going to identify which quantity in this relationship is the dependent quantity. Well, dependent means the same thing as output. And we know that our output variable or quantity is m, the number of miles. Independent is inside, it's our input. So the independent quantity in this situation is h, which represents the number of hours. So when talking about independent and dependent quantities, we should be able to write what are called dependency statements. We've got to decide which of the following statements is true. A, the number of hours depends on the number of miles, or B, the number of miles depends on the number of hours. Well, B just logically makes sense. Obviously, the number of miles Jay can ride depends on how many hours he's been riding. So B makes the most sense, but here's mathematically why. We said that the dependent variable is always the variable that depends on the independent variable. So B is written in the correct order. Dependent depends on the independent. Correct answer is B. Let's do one more problem from that same situation. It says that after work, Jay only has 4 hours to ride his bike before it gets dark. What domain and range are reasonable for this situation? We're going to use the function given here, m equals 12h, and we're going to plug in 4 hours into our function. Well, since it's 4 hours, this represents our h value. H is equal to 4. So using our function, m equals 12h, we're going to substitute in a 4 in place of h. So let's find the number of miles that he can ride if he rides all 4 hours. So m equals 12 times 4, and 12 times 4 is 48. So now let's write the domain and range that are reasonable for this situation. The domain in this problem, we know, well, always domain is x, but in this problem, our input, or x variable, is actually h, the number of hours he's been writing. R, which always represents y, in this case our output, is m. So the range here represents the number of miles he's been writing. So for the domain, h, the number of hours he can ride, well, he can ride anywhere from 0 to 4 hours. Okay, he could ride half an hour, 1 hour, 2 hours, so he could ride any amount of hours between 0 and 4. That sounds like a compound inequality. In other words, he can ride more than 0 hours, but less than 4 hours, and he could ride exactly 0 or 4. So we put an equal to underneath. Same thing for the range. The range represents the number of miles that he can ride. Well, if he doesn't ride at all, if he doesn't go and ride his bike at all, he would ride for 0 hours. Well, that would mean he would ride 0 miles. And then we found the biggest he can ride is 48 miles. That's the largest number of miles. And then m can be any number in between. So he can ride anywhere between 0 and 48 miles. This concludes part 1 of this lesson. Tune in to part 2 to try some more examples.